In section 3 of chapter 4, we're going to be solving quadratic equations by factoring them. Remember, the quadratic equations are in the form x squared plus bx plus c equals 0, and that is the standard form. We're going to leave them that way for now. Before we can begin, we need to make sure that we're speaking in the same language. So let's get some terms under our belt. A monomial means one, so a monomial is going to be a single term. So that could be just a number, it could be a variable, or it could be a number multiplied by a variable, like 3x. So a number and a variable multiplied together. So that would be a monomial, or one term. A binomial, bi meaning two, is the sum of two monomials. And an example of that would be like x minus 4. A trinomial are the ones we're talking about here. They're a sum of three monomials. And so that may look like x squared plus 2x plus 15, or some such thing. So a trinomial is 3. And if you'll remember back to Algebra 1, what we did when we multiplied binomials, we could multiply those by making sure we multiplied every part by every part. And you probably did that by using the FOIL method. The FOIL being first, outside, inside, last. So when you multiplied the first terms, that would be the x times the x, which gave you x squared. The outside was 7 times the x, which gave you the 7x. The inside terms were 4 times x, and the last terms were 4 times 7. So first, outside, inside, last. So your final answer would have been x squared plus 11x plus 28. So by looking at it from that direction, what we're going to do now is we're going to factor, and we're going to go backwards, or we're going to almost divide these trinomials. So we're going to end up with, if we start out with x squared plus bx plus c, we want to end up now with x plus some number times x plus some other number. And if you can look back and see from when we multiplied and used FOIL, the b term, the term right in front of your x, came from these two numbers added together. The 11 came from the 4 plus 7. So the b is going to be the same as m plus n. Our c term, the last term, the constant, came from when we multiplied our last terms, the 4 times 7. So c is going to be the product of the two constants usually, but the second terms in our binomials here. So our trick is going to be to find a set of numbers that multiply together to get our third term, but that add together to get our second term. So we do that by looking at, well, what numbers do we multiply together? You're going to start actually with your third term. The first term is easy in this case because x squared is just x times x. So you want to get back to where we started before. We want to get back to two binomials multiplied together. So the x squared came from x times x. That part's easy. Our second terms are going to be multiplied together to get the 48. So we've got to decide, well, what did we multiply together to get 48? So in this case, we've got several factors. We've got 1 times 48. We've got 2 times 24. We've got 3 times 16. We've got 4 times 12. 5 doesn't work. We've got 6 times 8. And 7, we're done. So these are the numbers we multiply together to get 48. We need some combination of these to add together to get 14. So in this case, we can quickly and easily rule out all of these that are larger than 14. 4 plus 12 is definitely larger. 6 plus 8 does happen to equal 14. So those are our two numbers. And there are our factors. See if you can work this one. Pause the video and work it out and see if you end up with the same answer I do. Your first term is x squared, so that's easy, x times x. Your last terms need to multiply together to get 20, so your factors are 1 and 20, 2 and 10, 4 and 5. And so obviously 4 times 5 and 4 plus 5 are going to be our two combinations. Now you need to be careful and watch. We need to add together to get a positive number. We need to, multiply to get a positive number. We need to add together and get a negative number. So if this third number is positive, then your signs are going to be the same. So if the third term is positive, then your signs are going to be the same. If your signs are the same, they can either be positive or both negative. In this case, we need them to add together to be negative, so both of them are going to be negative. And so negative 4 and negative 5 do indeed equal negative 9. See if you can work this one. X squared minus 9x minus 5. Work it out, pause it, work it out, and then come back. X squared obviously is x times x. 5 is easy, right? It's just 1 times 5. But it's negative, so one is positive and one is negative. One of my terms is positive and one of my terms is negative. So now instead of adding together to get this middle term, we need to subtract to get the middle term. So when we multiply, is there any combination that we can do with 1 and 5 to get 9? And the answer actually is no. So sometimes a trinomial is not factorable. So in this case, your answer is simply no factors. So not factorable or no factors or just can't be factored. All right, try this one. X squared minus 3x minus 18. Try it on your own and then come back. X squared is x times x. That part's easy. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that's all of them. So now we multiply together to get a negative. So if you're multiplying to get a negative, one has to be positive and one has to be negative. So your signs are different, and if your signs are different and you're adding, that means you're actually finding a difference or you're subtracting. So we want to subtract the two numbers and get a 3. So if you look down, 18 minus 1 is not going to give you 3. 9 minus 2 is not going to give you 3. 6 minus 3 does get you 3. So when you put the combination in, though, you need your answer of 3 to be negative. So you want your bigger number to be the negative number. So your 6 is going to be negative and your 3 is going to be positive. So a couple of key things here. If your third term is positive, your signs are the same. If your third term is negative, your signs are different. And then if your signs are different, you're going to subtract them, and the larger number is going to have the sign of this second term. If you're adding, then both signs, or if your answer is positive, then both signs are going to have whatever sign is on that middle term. All right, now you can tell that there's a lot of trial and error happening when you're factoring, and I actually don't care for trial and error. I like math because it's always, you follow a formula, you get an answer. But sometimes with factoring, you just have to use trial and error until you get it. There are a few types, though, that do have formulas and that turn out nice and neat and easy, and you can recognize every time. You may recognize these from when you used FOIL in Algebra 1, and then again you may not, and so that's okay, that's why we'll cover it. All right, so there are special products that you can recognize, and the more you do, the more you'll recognize these. The first is the difference of two squares. What that simply means is one perfect square minus another perfect square. And if you have something like that, what happens is those middle terms dropped out when you multiplied. So let's say x minus 2 times x plus 2. When you used FOIL, your first terms are indeed that x squared. Your outside terms are a positive 2x and a negative 2x. And your last term is that perfect square of 2 times 2 is 4. So if you'll look, when you have two binomials that are the same except for their signs in the middle, that means that when you multiply the outsides and the insides, the number is the same except it has opposite signs. And that's simply going to drop out, which leaves you just with a perfect square minus the perfect square. So that's why that happens, and that's how you can recognize it. The perfect square trinomial is a little bit trickier to recognize, but still it's a formula that you can recognize and see, there we go, we have an easy one. So x squared plus 2ab plus b squared equals a plus b squared. So let's look at something like, I wonder if I have an example in my notes or not. No, you know what happens when I make stuff up. Here we go, let's do x plus 3. X plus 3 squared simply means x plus 3 times x plus 3. So when you do your first outside, inside, last, your first terms are just going to be the first term squared, which is where you get the a squared. Your outside and your inside are both going to be the same. So you're going to have 3x here and 3x here. That's where you get 2 times this number, because you're adding it, you're just adding it twice. So that's where you get x squared plus 6x is the 2 times the 3, and then your last term is just the 3 times the 3, which is 9, which is the same as this term squared. All right. The same thing will happen if you're subtracting in between, and what happens there is your middle term is negative. So if this were x minus 3, the difference is going to be that we had a negative 3x and a negative 3x. And so now this negative 3 and negative 3 is negative 6. So that's why the difference there. So the only thing that changes is that middle term. If your binomial is negative, your middle term will be negative. But when we multiply a negative times a negative, we get a positive. So that's why the third term is always going to be positive. All right, so let's have you do some. Let's factor them and look backwards if you have, and I do have some of these written down so that I don't make stuff up that is weird. So get started on them as I write them. And then you can go ahead and pause until you get them all finished, and then come back and make sure that you got them all right. All right? On the first one, you're going to look to see, ooh, this is a perfect square minus a perfect square, because the square root of 121 is 11. So you can say, oh, this is just m plus 11 times m minus 11, and be done. And if you want to check it with FOIL, you certainly can. M times m is m squared. Negative 11m, positive 11 drops out. And then 11 times 11 is negative 121 because one's positive and one's negative. The same thing here, or not the same thing. So r squared, r is the square root of r squared. 7 is the square root of 49. And if you take 7 times 2, 7 and 7 are 14. So that's just r plus 7 quantity squared. All right, same type of thing here. You notice that, oh, this is a perfect square. So the square root of that is just p. This is a perfect square. 144 is 12 times 12. If you start recognizing your perfect squares, this will be a lot easier. So there's 12 there. And 12 plus 12 is indeed 24. 12 times 2 is 24. This one is negative, though. So you want p minus 12 quantity squared in that one. All right? And those follow exactly the formulas that we had here. Now, if we want, the whole reason we're doing this is we went back to, well, we want to solve the quadratic equations. What we need to know from here is if we have factors that we're multiplying together, we can use the zero product property, and that simply is that if you multiply 0 times any number, you're going to end up with 0. We're going to add another term, roots. Roots are simply the solutions to a quadratic equation. So roots, if I say find the roots, that means, well, find the answer, find the solutions to a quadratic equation. All right, if we know, let's do them this way. If we factored out and we got, oh, well, our factored equation is x plus 5 times x plus 2. If we know that equals 0, we can know that one or the other of these answers has to be 0. Because in order to get an answer of 0 when you multiply two numbers, one of those numbers that you multiplied had to be 0. So when you're solving an equation that looks like this, what you're going to do is, well, there are two possible solutions. Either x plus 5 equals 0 or x plus 2 equals 0. So then once you get to there, you're going to do just a quick subtract 5 from each side. So x is negative 5. Subtract 2 from both sides, or x is negative 2. So your two solutions in this case are negative 5 or negative 2. So you could put that as negative 5, negative 2, but you wouldn't put it in, this isn't a point, so you wouldn't put it in the parentheses. All right. We know that there's going to be two answers because this is a squared term. This tells us how many answers we're going to have. Sometimes if it's a perfect square, you'll only have one answer because that answer is duplicated. But we can have up to two answers in a quadratic equation. Let's see. Let's have you do one. So what I'll give you is something that looks like this. X squared minus x minus 42 equals 0. And I'll say find the roots. And what that means is find the answers. What do you multiply together to get 0? When is this a true statement? So the steps to do that is, first, you're simply going to factor. And if you remember how to do that, then shut it off and do it without me. And then come back. So you're going to have x times x equals x squared. Your 42 is going to be negative, so one is positive and one is negative. You're going to multiply together to get 42, but you want it to subtract to get a negative 1. So I know that 6 times 7 is 42. So that's the one I want. And I want the larger number to be negative, so the 7 is going to be the negative. So x plus 6, x minus 7. So after you factor, then you're going to set each binomial or each factor equal to 0. Because this times this equals 0, one or the other of them has to equal 0 in order to make that a true statement. So you just set x plus 6 equals 0 and x minus 7 equal to 0, and then solve. So x is negative 6 or a positive 7. And those are your two answers to that. That's how you find the roots. All right, so what good does this do us? Ha ha ha. You knew I was going to bring in a word problem. So if you have a garden that's 15 foot by 10 foot and you want to double the area of that garden by adding the same distance to the length and to the width of your garden, how much are you going to add and what are your new dimensions going to be? So first you're going to need to come up with an equation. So we've got we're going to have 15 by 10 is going to be the area, but we're going to add something to it. So we're going to have 10 plus something times 15 plus something. And we want that to equal 2 times our 15 times 10, which is 150. So now in order to solve this, we're going to have to get it into this type of format. So in order to get it into this type of format, first we're going to have to multiply through and use FOIL, and then we're going to have to rearrange the numbers to where it's in standard form. So 10 times 15 is 150 plus 10x plus 15x plus x squared is going to equal 300. Combining like terms and subtracting the 300. So let's combine here, 150 plus 25x plus x squared equals 300. So what I'm going to do is I'm going to manipulate the numbers and just switch it around to put it in the right order. The x squared is still positive over here, x squared, and I'm going to move the 25x next. And then I'm going to add 150, and then I'm going to subtract 300 from both sides so that I end up with 0. Which is what I want. So then when I subtract that, I ended up with a negative 150. Now, I finally have a form that looks like this that we can solve, and hopefully I'm not low enough that I'm out of the viewer. Oh boy. All right. So once again, factor. If you can shut it off and do it on your own, do it quick. Here we go. X times x is x squared. You want to be a negative number, so you're going to have one positive and one negative. You want to multiply to get 150, but you want to add together to get 25. So if you do, hopefully you turned it off and you did those numbers on your own to find them. So if you took 30 times 5, you would get 150, and 30 minus 5 is your 25. So there's your two binomials. When you set each of those equal to 0, oops. So subtract 30 and add 5. So x is negative 30 or 5. So then what you have to do is you just use practical knowledge, right? Can you have a negative distance? No, you can't. So in this case, with a word problem, you only have one possible solution, even though mathematically you have two possible solutions. The negative 30 is not going to work. So 5 is your x. So your answer is 5 is the amount that you're going to add. So you'll add 5 feet. And then if you add 5 feet to each of those, your new dimensions are 20 by 15. And that would be your final answer. All right, one more thing, because you know I can't stop there. And I lost the lid to my marker. Oh my goodness. Okay. All right, so the last thing is this. If you will remember, we had another form of quadratic equations that wasn't just in standard form. We also had, if you'll remember, we found the intercept form. If you'll remember, the intercept form was y equals a times, was it p or q first? X minus p? Yep. And times x minus q. And if you'll look, that looks an awful lot like a factored equation. So it actually is. So what we're finding when we find the roots, it's where does that parabola cross the x-axis? So we can either solve it the way we did by factoring and then setting them equal to 0, or you can recognize that if you put this into the intercept form, the negative of the p and the negative of the q, the opposite of the p and the q, are going to be your roots. So here's an example of that. So in order to put a standard form into into your intercept form, you're simply going to factor, just like you did before. So x times x is x squared. Your negative means that you're going to have one positive and one negative. Your factors are going to be 1 and 28, 2 and 14, 3, 28, 8, 9, 10, nope, 4 and 7. Ah, this is looking promising. Because they're opposite signs, we've got to subtract to get the 3, and 7 minus 4 is indeed 3. And we want the 3 to be negative, so we want our larger number to be negative. So 7 will be our negative number, 4 will be our positive number. So now we're in this format. So our roots are 4 and 7, but be careful because it's negative p. So the negative of a positive is negative 4. And negative q, the negative of a negative, is just positive 7. All right, so there's where our roots come from. And let's see, I was going to give you one more to do, but you know what? If I don't have an example to give you. All right, x squared plus 5x minus 14. Is that what I said? 5x minus 14. Turn it off and do it on your own. Did you turn it off? Okay, here we go. Factoring. It's going to be opposite. One positive and one negative. And we're going to multiply together to get 14 and subtract to get 5. So we need, 2 times 7 is 14 and the difference is 5. We want the positive, we want the largest number to be positive, so the 7 is positive and the 2 is negative. So just checking, x squared, negative 14, outsides and insides, negative 2x, positive 7x is positive 5x. So your roots, don't forget, did you do this on your own before you turned it back on? What are your roots? Your roots are negative 7 and positive 2. Nice job.